Alright, so let us begin with the theory of the Leibniz rule for, for derivative under integral sign. And as I've mentioned there, that it's very much useful for the upcoming Feynman techniques analysis. Okay, so what's the main topic here is that in general, we know that using the standard Leibniz rule, we can evaluate a function derivative if it's given in the form of f of t with respect to dt integral from, let us say, f of x to g of x, like from hx to gx with respect to dx, right? So in general, this could be written as g prime of x f of x minus of h prime of x f of x, right? And this and what I'm trying to tell is the derivative of gx multiplied by fx minus of the derivative of hx multiplied by f of hx. Okay, yeah, so this is f of hx, f of gx, f of gx multiplied by f of hx. So this is the standard Leibniz rule, right? But the thing is that what if this function is not given in f of t? If this function is given in the form of f of x comma t, let us say that if I need to evaluate the integral from phi of x to psi of x of f of x comma t with respect to dt, what to do in this case? How I could evaluate it? So basically, in this case, one more step would be counted extra, and all the things would be exactly same. What is that? And it should be noted very much carefully. So first of all, I would write the integral from phi of x to psi of x. Okay, and I'll take the partial derivative. Okay, this is the main thing. The partial derivative of this function f of x comma t. Okay, f of x comma t with respect to dt, and then evaluate the integral with respect to dt. Okay, and after that we will do the same thing, that is d over of dx of psi of x multiplied by f of x comma, and we will replace t by psi of x as previous, minus of d over of dx of psi of x. Okay, so minus of d over of dx of psi of x f of x comma phi of x. Okay, all right. So this is the way that how I could evaluate it. Now, based on this, we can see some kind of examples from there. So like in this case, the first thing that okay, I'll see is that this is given in the form of x comma t. This function is given in the form of x comma t. So I'll apply the partial derivative, that is the integral from x to x square, and the partial derivative is t cos of xt with respect to dt, plus of the derivative of x square, that is 2x. Yeah, and now we'll be doing the same thing that we were doing before, so that is sine of x cube minus of 1, that is the derivative of x multiplied by sine of x square, right? Let us move on forward. So again, I'll, as this is of the form of x comma t, there are two variables, so this would be 0 to ln x t e to the power of xt with respect to dt, plus of the derivative of ln x, that is e to the power of x e to the power of x ln x minus of 0. Again, I'll take the partial derivative. Okay, so that is root x to 2x t over of t square plus of x square. Okay, so the derivative is t minus of this would be minus of 2t x, right, divided by t square plus of x square whole square with respect to dt plus of 2 multiplied by, that is the derivative of 2x multiplied by putting or replacing the function with 2x. So that would be 2x over of 2x whole square plus of x square minus of half root x over of x plus of x square. Right. So this is our answer. Again, the same thing. I'll do the partial derivative first with respect to x. So this would be minus of 2x t square over of 1 over of x square t square whole square with respect to dt. Okay. So yeah, plus of 0, since the derivative of pi by 2 is 0, minus of the derivative of arc tan x is basically 1 over of x square, 1 over of replacing it with tan inverse of x whole square t square x square. Yeah, so this is our answer. Again, next question. So yeah, there, this would be from 0 to sine x, taking the partial derivative, that would be 1 plus of xt t with respect to dt. The derivative of cosine sine x is cosine x multiplied by ln of 1 plus of x sine of x, right, minus of 0, since the derivative of 0 is 0. Again, the same thing, the partial derivative from, so this would be minus of ln t. uh, okay, but wait, as I can see that this question is given in only t, right? So okay, in that case also, if you will evaluate it using the partial derivative, you will be getting the partial derivative as 0, right? So after that, this would be 3x square over of ln of x cube minus of 2x over of ln of x square. So yeah, here's our answer. So this is how we can evaluate it. And yeah, this technique is so useful that in the upcoming Pyman's technique analysis, we can use this technique more and more efficiently. And this is the one of the most important things ever in calculus. So yeah, so this was all about if the function is given in the form of x comma t, and I believe that this is the universal Leibniz rule. Okay, and this is the universal Leibniz rule. So okay, we can see one more problem. So let us do it. So okay, this much is enough.